Hello again, student. I'm teacher Kashmir and I'm a mathematics teacher. Today, I'm going to discuss with you one of the topic that I have selected from the IGCSE syllabus for year 11. Now, the unit is 19.4, which is angle relationships in circles. Now, if you have the Cambridge course book, as what you see on the screen, you can turn to the page 407. Now, students, look at this circle. We draw a diameter and I draw two lines connecting the end of the diameter to the circumference. The question is, what is the angle formed? Very good. The angle formed is 90 degrees. Now we try that again. I'm going to draw another diameter. However, this time I'm going to draw the triangle upwards and make sure that it is touching the circumference of the circle. So we still get the 90 degrees. So basically the angle in a semicircle is always a right angle triangle. It's a right angle. Right. Now, can we draw a radius and another radius? As what we know that we can draw as many radii as possible in a circle. Now, let us just connect the two radii. And do you agree that now we have a triangle? Now, if I ask you what kind of triangle that we are having, would you be able to answer? Very good, because the two radii are of the same length and the triangle is an isosceles triangle. So in isosceles triangle, there are two sides which are equal in length, and as a result, the two angles at the bottom are also equal in size. Very quick question here. Now you are supposed to figure out the value of each angle at the bottom. Given the angle at the top is 100 degrees. Very good. Each of them will share 40 and 40. Why? Now this is because in a triangle, the total sum of the interior angle is 180 degrees. Now look at this circle. I just draw another two radii as what we did just now. However, I draw another two lines which is directly from the legs of the radii to the circumference. Well, shall I say that the shape that we get here is similar to the navigation shape? The question is that what would be the relationship between those two angles? Well, if I give you the angle which is subtended to the center is 100 degrees, what would be the value of the angle subtended to the circumference? It is actually half of it. It's a 50. So the angle at the center of a circle is always twice the angle at the circumference. Now let's try that again, but now I want to drag the value or the shape more to the right hand side. Well, we still have the navigation shape, but it is not really a perfect one. But now do you think that we are still getting the same answer as what we get just now? Yes, we do. It is still half of the value of the angle subtended to the center. We move further to the right. It's overlapping now. Yes, it's still a 50 degrees. We move again too far to the right, we still get the 50 degrees. Now this is the original shape, if you still remember. Now I just want you to actually look at the other diagram in a short while. I'm going to draw the same navigation shape, but now the radius is wider. Can you still see that this is also a navigation shape? Yes, very good. So now I give you a wider angle here, which is 150. So we just try to figure out what is the value here, and we know that it should be half from the value of the 150. So very good. The value is 75 degrees. Okay. Okay. Okay, this is the one. So the value here is 240. So basically here will be half of it. So do you agree if I say this is a 120 degrees? Okay, about the navigation shape, can we look into another characteristic of angles in a circle? Now, I just take 2 points on the circumference, and this is actually an arc, all right, an arc of a circle. What I do, I just draw a line connecting the arcs and subtended to the circumference. Now I use the same legs to draw another shape. However, it is actually attached to another circumference. Now, the thing is that it looks now like a butterfly shape. And what would be the characteristic of angle inside? Now, basically, the value of the two angles on top should always be similar. And the value of the two angles down should also be similar. So, next one. Alright, now this is like an M shape. I mean the letter M. Okay, but you must bear in mind that the arc should be equal in length. If we have arcs which are equal in length, the angle subtended to the circumference should always be the same. Okay, we go further. The next diagram. Oh, what is this? This is a straight line, alright. It's a diameter. Oops. Okay. Alright. Now this is like a pencil shape. That's what you can see. Okay. The condition is that the two arcs must be of the same length. And again, what we can conclude here is that the two angles at the end of the circumference should always be similar. Now, we're going to draw 4 radii, okay, which at the end will form a cross or like an X shape. And if we have the value of the length of the arc similar on top and at the bottom, okay, we get an X shape there. So the value of the angle subtended to the center should always be similar. Now, this is a cyclic quadrilateral. Now, what does it mean by a cyclic quadrilateral? Is that you are drawing a quadrilateral inside a circle, and the condition is that all the vertices must be in contact with the circumference. Now, there are 4 angles here, and we know that in one quadrilateral the total sum of the interior angle should always be 360 degrees. Now, a very quick example. If I give you one of the angle is 100 degrees and the other one is 70 degrees, what would be the value of x and y? Alright, the answer is very easy. We know that the total sum is always 360 degrees. However, there is a connection between the two sides which is opposite, the two angles which are opposite to each other. So the 100 degree and the y actually will total up to become 180. So the value of y should be 80 degrees. So I think you get an idea on how much is the value for x. Again, the opposite side will give you 180 degree. And since we already have 70 degrees here, okay, so the value of the other angle should be 110 degrees. Now, do you think this is a cyclic quadrilateral? Yes? No? Now, basically, if your answer is yes, you get an incorrect answer. Because we know that in order to become a cyclic quadrilateral, all the vertices, okay, all the vertices must touch the circumference. But the problem is, one of the vertex is not touching the circumference, but it is touching only at the center. So a very quick question here. If I give you the value of one of the angle as stated is 100 degrees, what do you think the value of the question mark? Well, to make things easy for you, let us try this method. I just an imaginary line connecting the two radius, radius and radius, directly to the circumference. Okay, now do you agree now we have a navigation shape? And we agree that the angle subtended to the circumference is always half of the angle subtended to the center. So it's 50. But that is not the answer. That is not what we are looking for. Alright, now I just delete the radius for a while. And now we have a cyclic quadrilateral because all the vertices are actually touching the circumference. And we know that the relationship between the opposite angles in a quadrilateral, in a cyclic quadrilateral. So if one value of the angle is 50 degrees, the other value should be very good. It's 130 degrees. Now, now we already get the answer. Okay, so the answer should be 130 degrees. Let me just quickly show it to you again if you get confused just now. Now I use another diagram here. So the question is asking you what is the value of that angle. Alright, now we draw an imaginary line and we just put aside the bottom part of the diagrams for a while because I want you to see the navigation shape. So here is 100 degrees and at the end will be 50 degrees. That is normal and you know it already. So we just put it back and we delete. We just look into the, what do you call that? The cyclic quadrilateral now. So the relationship between the two opposite angles should be 180 degrees, which at the end will give you 130 degrees as your final answer. I just love maths. And if you think the video just now benefits you, please subscribe to my channel. I'm Teacher Kashmir. Thank you for listening.